Okay, so here's part C, where we used a different mathematical function called polynomial mod to look at these powers of x plus 1 mod 2. So first of all, what does it even mean? Like, what does it mean when we had a shortcut for writing this, that x plus 1 squared was 101?
So that meant we had an odd coefficient for the x's, an even coefficient, we had the odd coefficient for x squared, the even coefficient for x's, an odd coefficient for the ones.
Okay, so what was x plus 1 squared?
X squared plus 2x plus 1.
Okay, so I'll write it out the way you said it. You pointed to this one for the x squared? Or this one?
That one.
Okay, so x squared plus 2x plus 1 became 101. So what did that mean?
It means we had an odd coefficient here,
Which was what?
1.
1x squared, okay.
An even coefficient here, which is 2.
Okay,
an
so
odd coefficient for the ones.
Why did the 2 become a 0?
Because mod 2, you can only have zeros, which are multiples of 2, and ones, which aren't.
Okay, interesting. So that was our pattern. So x plus 1 to the 5th became x to the 5th plus x to the 4th plus no x cubes plus no x squareds plus 1x plus 1. All right, and what are some patterns that you noticed here in this one?
Well, if it kind of starts to see triangles, like if these are the smallest triangles, you can't. Those don't look like triangles.
No.
And then these are kind of triangles. This one is a triangle.
This kind of looks like a triangle.
And then those are the small triangles. And then this is starting to be a very big triangle.
Oh, interesting. Okay.
So this looks like Sierpinski's triangle a little bit.
Does look like
Triangles.
triangle.
Lots of times we see Pascal's triangle. There's a way to get to Sierpinski's triangle.
Yeah, there is. Do you notice any other patterns in here besides the Sierpinski's triangle? Are there other interesting patterns happening?
Well, like every time there's like the big triangles end, there's this row here
Yeah.
where there's all ones.
Where do those all one rows occur?
1 less than the power of 2.
Oh, wow. Interesting. It seems like we always get rows that are ones and 1 less than a power of 2. Now, we don't have polynomial mod on camera, but what would be the next one that you think would have all ones in it?
15.
All right, so I'll do it right here on the screen. 15.
And yep, it does.
So how interesting is that?
And then the powers of 2 have everything except the outermost layer is 0.
Aha. Even here that's true. This is a power of 2, 1 is a power of 2, right? Everything but the outermost layers is 0.
Yep. And
Technically, yes.
well,
Technically,
and also
yes.
everything is 1
Also everything is 1. Why?
because it's 1 less than 5 2.
It's also 1 less than a power of 2. So that's fun. Maybe this is enough for this morning because you guys played with this for a while. But what we're going to do tomorrow is instead of x squared plus x plus, instead of x plus 1 that we looked at today, Dave Radcliffe looked at x squared plus x plus 1 to the end and found some really cool patterns. So that's what we're going to explore tomorrow.
Okay.
Alright.
All right, high five, guys. Good work. Oh, wait, no high pink high five. Air 5. Good job.